Okay, let's have a look at this particular question, which involves Newton's third law. What we have is two masses, each with 1 kilogram, so the total combined mass is a 2 kilogram mass, subjected to a 10 Newton pushing force. It's on a frictionless surface. The question asks to calculate the force that block A applies to block B, which we've referred to as F subscript A on B. Now this question needs to be done in two parts. What we do is consider the entire mass as a single 2 kilogram mass subjected to a net force of 10 newtons, and applying F equals ma to the whole system, we see that the 10 newton force applied to the 2 kilogram mass produces an acceleration of 5 meters per second squared. Now, after having considered that, we realize that the second block, block B, must also have the same acceleration, 5 meters per second squared. The only force that block B feels is the force of being pushed by block A, that is, force of A on B. So whatever this force is, it must be sufficient to create the acceleration of 5 meters per second squared. And by considering block B as a single 1 kilogram mass subjected by a pushing force from block A, we now apply F equals ma to only the second block. Since the mass is 1 kilogram and the acceleration is already known as 5 meters per second squared, this implies that the net force must be 5 newtons, provided by block A alone. Now, one nice way to think about this is the 10 Newton force applies a force to the whole system which is distributed evenly between both masses. So each of the two equal masses receives a net force of 5 newtons. This means that the 5 Newton force pushing on block B is the reaction force to the 5 newtons that block B pushes backwards on block A, not shown. And if we consider it in those terms, block A has a 10 Newton force forwards and a 5 Newton force backwards, so therefore also receives a net force of 5 newtons for that single block. Each block takes whatever force it needs to accelerate it at the acceleration given or calculated, and the remaining force is passed on. 10 newtons applies to block A, it uses 5 of those newtons to accelerate and passes the remaining 5 on.